Hi, this is your Professor Sudha Kolathu Parambil, Section 8.1 Confidence Interval for a population mean sigma known. This section has 4 objectives. In Objective 1, you are going to learn how to construct and interpret confidence intervals for a population mean when the population standard deviation is known. Recall that the sample mean is x bar and population mean mu and population proportion p. So let's look at Objective 1, estimating a population mean. How can we measure the reading ability of elementary school students? A certain school is trying to find out a new experimental approach to teach reading to 4th graders. So a sample random of 100 4th graders are selected to take part in a new experimental approach to teach reading. At the end of the program, the students are given a standardized reading test. On the basis of past result, it is known that the scores on this test have a population standard deviation 15. The sample mean score for 100 students was 67.30. The administrators want to estimate what the mean score would be if the entire population of 4th graders in the districts had enrolled in the program. The best estimate for the population mean is the sample mean. The sample mean is a point estimate because it's a single number. A point estimate means that's a single number that is used to estimate the value of an unknown parameter. So a parameter means a parameter is a numerical summary of population such as population mean or a population proportion. It is very unlikely that the sample mean is exactly equal to the population mean of all 4th graders. Therefore, in order for the estimate to be useful, we must decide how close it is likely to be. For example, if we think that it could be off by 10 points. For 100 4th graders, mean is 67.30. If you are considering the entire student in district or all 4th graders, we are assuming that it could be off by 10 points. That means population mean will be plus or minus 10 points from the sample mean. So this will be 67.30 plus 10, that is 77.30, and 67.30 minus 10, that is 57.30. So we can write mu is actually between 57.30 and 77.30. So the estimate of the population mean is within this interval. Or this one we can write it in short form like 67.30 plus or minus 10. So this is the interval, and this one plus or minus 10, this plus or minus number is called the margin of error. So right now you learned new wordings like point estimate and margin of error, and you learned what is the meaning of plus or minus. Plus or minus means we are adding and subtracting a number from the mean, and that number is called the margin of error. And the best estimate for the population mean is the sample mean, and sample mean is the point estimate. And we will add the margin of error to the point estimate to find the interval. We need to determine how large to make the margin of error so that the interval is likely to contain the population mean. To do this, we use the sampling distribution of the sample mean. Our sample size has 100 students. Since the sample size is greater than 30, the central limit theorem tells us that the sampling distribution of sample mean is approximately normal with mean mu and standard deviation sigma divided by square root of n. The standard deviation is also called the standard error sigma divided by square root of n. So in our example, the standard error is 15 divided by square root of 100, that is equal 1.5. Now you learn one more new word, standard error, which is sigma divided by square root of n. We will now construct a 95% confidence interval for mu. First draw a normal curve. 95% means in decimal 0.95. So this is the area, and remaining is 1 minus 0.95, that is 0.5. So sum of these two areas should be 0.5. So 0.5 divided by 2, that is 0.025. That's why these two area 0.025. Now I want to find the z-score corresponding to this area. So this area is 0.025. So look at table A2 for cumulative normal distribution to find the z-score. So now I am looking at the table. I am trying to find the area close to 0.025. Okay, I can see that here. So that corresponds to negative 1.9 and at the top 0.06. So negative 1.96. Since we have equal area on both sides, the z-score will be 1.96 and negative 1.96. The value 1.96 is called the critical value, because one is negative, other one is positive. So 1.96 is the critical value. To obtain the margin of error, multiply the critical value by the standard error. So margin of error is critical value times the standard error. So 1.96 times the standard error is 1.5, that is equal 2.94. We calculated the standard error in the previous page using the formula sigma divided by square root of n. You can find the critical value using the calculator also. So if you are using TIAT for calculator, you can enter inverse norm 0.25 and mu is 0 and sigma 1. And this is the area. Now we find the margin of error. So the population mean mu is actually x bar sample mean plus or minus the margin of error. So mu equal 67.30 plus or minus 2.94. So we get two values, one with the plus sign and another with the minus sign. And we can write the interval in three different forms. Mu equals 67.30 plus or minus 2.94, like this. Or we can write mu is in this interval, like interval form. Or we can write using the inequality mu is between these two numbers. So in other words, we would say we are 95% confident that the population mean is between 64.36 and 70.24. So now you learn how to construct the confidence interval. This is how I memorize the formula. Mu is between, that means mu belongs to this interval. Interval I am going to write, that is sample mean plus or minus the margin of error, right? So margin of error we calculated using the formula critical value times the standard error. So the critical value is the z-score. So I can write z times sigma divided by square root of n. So z times sigma over square root of n. Confidence level. Based on the sample of 100 fourth graders using new approach to teaching reading, a 95% confident interval for the mean score was constructed. So 95%, that is the confidence level for the confidence interval. The confidence level measures the success rate of the method used to construct the confidence interval. So a confident interval is an interval that is used to estimate the value of a parameter, and confidence level that measures the success rate of the method used to construct the confidence level. This is actually a percentage between 0% and 100%. But usually we use larger values such as 90%, 95% or 99% because we want to have a high confidence that our intervals contain the true value. Objective 2. Find the critical values for the confidence interval. In the previous example, the confidence level was 95% and we found the corresponding critical value as 1.96. 95% is the most commonly used confident interval, but sometimes we want to construct confident interval with a different level. So these are critical values for most commonly used confidence level. Let's look at this example. Sample mean and standard error are given. We need to construct a 90% confident interval for the population mean mu. I start the problem with confident interval for mu is sample mean plus or minus the margin of error, that is z score times sigma divided by square root of n. Then I will see what are the things given. So we know sample mean, so that is 7.1 plus or minus. We don't know the z score, so we need to find the z score correspond to 90% confident interval. For 90% confident interval, okay, we can use the table, or if you want you can use the TI-84 calculator to find the z score. So that is 1.645 and sigma over square root of n, that is given, that is 2.3. So first multiply these two, then add or subtract from 7.1. 3.8 if you round it to one decimal place. So we can write mu is between 7.1 minus 3.8 and 7.1 plus 3.8. Or you can write in the interval notation also. So this is 3.3 less than mu less than 10.9. Or you can write 3.3 comma 10.9. So this value, that is the margin of error. And remember that we calculated that by multiplying the critical value as the z score times the standard error. So we can say that the population mean is between 3.3 and 10.9. Z alpha notation. Sometime we may want to find a critical value for a confidence level not given in the table. To do this, it is useful to learn a notation for z score with the given area to its right. If 1 minus alpha is the confidence level, then the critical value is z alpha over 2. The notation z alpha that represents z, that is a z score with an area of alpha to its right. Z alpha over 2 that represents the z score with an area of alpha over 2 to its right. So in this example, if we have z alpha over 2 here, that means the area to its right, that is alpha over 2. So this is negative z alpha over 2. So this area also will be alpha over 2. So if you add 2 alpha over 2, like alpha over 2 plus alpha over 2, that makes it 2 alpha over 2, that is equal alpha. So the area of these two together, that is alpha. So this area That will be 1 minus alpha. Alpha is a number between 0 and 1. The total area under the curve is 100%, or in decimal that is 1. Now let's look at an example. Find the critical value z alpha over 2 for 92% confident interval. So the level is 92%. First we will draw a normal curve, then it will be easier to understand. This area is 92%, so that is 0.92. Area is 0.92. So sum of these two will be 1 minus 0.92, which is equal 1.08, and that is the sum of these two. So each one will be half of that, so divide that by 2, so 0.04. So this is actually the alpha, this is alpha divided by 2. So the critical value is z alpha divided by 2, or z 0.04. Since the area to the right side of z alpha over 2 is 0.04, so area to the left of that will be 1 minus 0.04, which is equal 0.96. Now we will look at the body of the table A2 and find the value close to 0.96. So that is 0.9599, and which correspond to the z-score 1.75. Or if you are using the calculator, use inverse norm, INV norm, and the area 0.96, mean and standard deviation, so 0, 1. You will get the same value if you round it to 2 decimal places. So we can write the z-score is equal 1.75. So now you learn how to find the critical value for 92% confidence interval. So z alpha over 2, that is z 0.04, that is equal 1.75. In this section we are learning how to find the confidence interval for a population mean when sigma is known. That means we assume that the population standard deviation is known. In practice, sigma is usually not known. We make this assumption because it allows us to use a familiar normal distribution. We will learn how to construct the confidence interval when sigma is unknown in the next section. Other assumptions for the method to describe here for constructing the confidence interval are: we have a simple random sample and the sample size is greater than 30, or the population is approximately normal. When these assumptions are satisfied, we can find the point estimate, then find the critical value, then find the standard error, then find the margin of error, then use the point estimate and the margin of error to construct the confidence interval, then interpret the result. So I'll explain the procedure again using an example. Please read this example and underline the important information. In this example, the sample mean and the standard deviation are given. That means sigma is known. We need to construct a 90% confidence interval for the mean fill weight. First we check for the assumption. The sample is a simple random sample and the population is known to be normal. The assumptions are met, so we may proceed. Confidence interval is point estimate plus or minus the margin of error. So point estimate is the sample mean, and we need to find the z-score, the critical value, and we know sigma. Sigma is known. Confidence level is 90%. So this area is 90%. Sum of these two area will be 10%. So this area will be 5%. 5% in decimal is 0.05. So alpha over 2 is 0.05. So we need to find z 0.05. So this area is 0.05 times this is 90%, so 0.9. So this entire area is 0.95. So if you are using the TI-84 calculator, press second, VARS and option INV NORM and enter 0.95, mu is 0 and sigma 1, and you will get that one equal 1.645. Or you can use the table, look at the last line on table A3 and find the critical value. You will get the same critical value. Or you can use the commonly used confidence level and the table to find the critical value. So if you are using this table, it is 90% confidence level. This is the critical value, that is same as this. So now we can substitute all those values here to find the confidence interval. So mean is 20.25, the critical value is here, and sigma 0.2, and square root of n is 6 boxes, so 6. Now calculate this. So if you add the margin of error, you will get 20.38. If we subtract the margin of error, you will get 20.12. So we can, here I rounded to 2 decimal places. So now we can write down the confidence interval. So this is the confidence interval. And now we can interpret the result. We are 90% confident that the mean weight mu is between 20.12 and 20.38. You can use the TI-84 calculator to find the confidence interval for a population mean when sigma is known. First press stat, use the arrow key, select test. Select option 7. You can use the arrow key or you can press 7. Then highlight stat, press enter. And I'm going to use the values from the previous example, 0.2, 20.25, and the sample size 6, and the confidence level 0.9. Then highlight calculate, press enter. It will give you the interval. Round that to 2 decimal places. So let me write down the steps. Press stat, then test, then option 7, then highlight stats, and then you will get this window. Then enter the value for sigma, mean, the sample size and the confidence level, then highlight calculate and press enter. Objective 3, describe the relationship between the confidence level and the margin of error. If we want to increase our confidence that an interval contains a true value, we must increase the critical value. This increases the margin of error, which makes the confidence interval wider. We would rather have a high level of confidence than a lower level. But we would also rather have a smaller margin of error than a larger one. So we have to choose a level of confidence that give a good balance. The most common choice is 95%. In some cases where high confidence is very important, a larger confidence level such as 99% may be chosen. In practical situations, the confidence level less than 90% are not considered to be reliable enough to be used. This diagram illustrates the trade-off between the confidence level and margin of error. 100 samples are drawn from a population with mean mu. The center diagram represents the 195% confidence level, each based on one of these samples. The left one, that is 70% confidence interval, based on the same sample. These intervals are narrower because they have smaller margin of error, but many of them fail to cover the population mean. You can see that here. These intervals are too unreliable to be of any practical value. The rightmost figure has 99.7 confidence interval. These intervals are very reliable, but they are wider due to larger margin of error, so they are not convey as much information. The leftmost diagram, the margin of error is small, but they cover the population mean only 70% of time. So this low success rate makes the 70% confidence level unacceptable for practical purpose. The rightmost diagram always succeeded in covering the population mean, but their margin of error is large. So the good compromise between the reliability and margin of error is the 95% confidence interval. In practical, we won't get to see where the mu is, where the vertical line that indicates where the true value of mu is. So we don't know whether we got the right confidence interval or not. What we do now is that our confidence interval was constructed by a method that succeeds 95% of time. The confidence level describes the success rate of the method used to construct a confidence interval, not the success of any particular interval. Objective 4. Find the sample size necessary to obtain a confidence interval of a given width. This is the formula for the margin of error. We can make the margin of error smaller if we are willing to reduce our level of confidence. Also, if we increase the sample size, that means dividing this number by a larger number, that means we'll get a smaller value. Then by doing that, we can reduce the margin of error. That means one way is increase the sample size. So I'm going to solve this formula for n to find the sample size necessary to obtain a confidence interval of a given width. First multiply both sides by square root of n. So these two cancel. Then divide both sides by m. So these two cancel. And you will get square root of n equal z alpha over 2 times sigma over m. Now in order to solve for n, square both sides. So if you square this, square and square root will cancel. You will get n equal to this whole thing. So we can write the formula n is equal z alpha over 2 times sigma divided by m square. Here m represents the margin of error. While calculating n, if you won't get a whole number, round up to the nearest whole number. Please read the question and underline the important information and identify what we need to find out. So sigma is given 3. The question is asking how many mice. So how many means number, so that is n, or the size, and 95%, that is the confidence interval, and margin of error m 0.05. First write down the formula to find n. N represent the minimum sample size. So in this formula we know sigma and m, but we don't know the critical value. So first find the critical value at 95% confidence interval. So this is 95%, that means 0.95. So remaining these two area will be, sum of these two area will be 5%. So each one will be 5% divided by 2, that is 2.5%, or in decimal 0.025. So this area is 0.025. So this area to the left side of this z score, or the critical value, z alpha over 2 is 0.025 plus 0.95, that is 0.975. So in the calculator, enter second VARS and select the option INV NORM and 0.975 mu and sigma 0,1. Then if you round that answer to 2 decimal places, you will get the critical value z alpha over 2 equal 1.96, and use that value to calculate n. So n equal 1.96 times sigma is 3, m is 0.5, then square all these. Then you will get that value approximately equal 138.30. So we need to round up here. So 139. So we must weigh 139 mice in order to obtain a 95% confidence interval with a margin of error 0.5 grams. Here we are rounding up because then we can make sure that the margin of error is not greater than 0.5 grams. The last objective in this section, objective 5, the distinguish between the confidence and the probability. Suppose that 90% confidence interval for a mean weight of a cereal box was computed to be 20.12 less than mu less than 20.38. That means the population mean is in this interval. It is tempting to say that the probability is 90%, that mu is between 20.12 and 20.38. The term probability refers to the random events which can come out differently when the experiments are repeated. But these numbers are fixed, not random. The population mean is also fixed, even if we don't know precisely what the value is. But the population mean weight is either between these two values. Therefore, we say that we have 90% confidence that the population mean is in this interval. In other words, let's say we are discussing a method used to construct a 90% confidence interval. The method will succeed in covering the population mean 90% of the time and fail 10% of time. Therefore, it is correct to say that the method of constructing 90% confidence interval has probability 90% of covering the population mean. In this section, you learn how to construct and interpret confidence interval for a population mean when the standard deviation is known. Next section you will learn when the population standard deviation is unknown. Also you learn how to find critical values for confidence intervals using the table and the calculator, and how to describe the relationship between the confidence interval and the margin of error, and how to find the sample size n necessary to find the confidence interval, and find the difference between the confidence and probability. Also remember the formula we used to calculate the confidence interval and the sample size.